Script complete, 941 words, target 900 within the 5% band. Here it is. Right now, Jupiter's innermost moon, Metis, is still spiraling inward, closer to the planet with every single orbit, and NASA's own orbital models cannot tell us exactly when it crosses the line that ends it. Jupiter is pulling it apart, slowly, relentlessly. And what's waiting for Metis at the end of that fall is something scientists only confirmed a few years ago, a process that means Jupiter has already done this before. Here's what nobody is telling you. Metis is small, barely 40 kilometers across. It orbits deeper inside Jupiter's grip than any other major moon, just above the cloud tops of the largest planet in our solar system. It moves faster than Jupiter itself rotates, completing a full lap in under 7 hours. That single fact is the problem. Because Metis orbits below what's called the synchronous point, Jupiter's gravity doesn't just hold it, it drags it. Every lap around the planet steals a little more of its orbital energy. Millimeter by millimeter, year by year, Metis is losing altitude, sinking deeper into a gravity well it can never climb back out of. Astronomers have watched this kind of decay before, on smaller bodies over shorter timescales. They know exactly where it ends, and that's the part that should unsettle you. There is a boundary around Jupiter called the Roche limit. Cross it and a moon's own gravity can no longer hold itself together against the planet pulling on its near side harder than its far side. Metis is heading straight for it. When it arrives, and models say it eventually will, the moon won't crash into Jupiter. It will come apart in orbit, piece by piece, rock by rock, stretched into a ribbon of debris circling a planet that just consumed one of its own children. No impact, no explosion. Just a slow, silent unraveling that could take centuries to finish, watched by nothing but Jupiter's own instruments. And here's the detail scientists don't say loudly enough. This has already happened before. Jupiter's faint, dusty rings, the ones almost no one has heard of, are not primordial. They are leftovers, evidence. You'd think a planet this well-studied would have a clean explanation ready. It doesn't. For decades, the assumption was that Jupiter's rings formed the same way Saturn's did, ice and rock left over from the solar system's birth. But Galileo and Juno data broke that idea apart. The ring material is wrong. Too dark, too fine, chemically wrong for primordial ice. The only source that fits is dust blasted off Metis, Adrastea, Amalthea, and Thebe, the 4 small moons living dangerously close to Jupiter right now. Caltech researchers modeling the impacts admit the numbers barely add up without assuming something bigger happened before. Something already got shredded, and whatever it was, it isn't in the historical record. Here's the part that changes how you should think about this. Micrometeorites hitting those 4 small moons knock dust loose constantly. That's the accepted, boring explanation for the visible rings. But it doesn't explain the rings' total mass. Researchers running the numbers found a gap, a meaningful one. To account for the material actually orbiting Jupiter, there needs to have been at least one moon-sized body torn apart entirely, sometime in the last few hundred million years recent, on a cosmic clock. Not billions of years ago, back when the solar system was still forming. Recent enough that it isn't ancient history. Recent enough that it could happen again, to a moon we can currently see, name, and track. It's a pattern, and Metis is next in line. What makes this genuinely strange is the timeline doesn't stay clean. Adrastea sits even closer to the Roche limit than Metis does. Both moons are decaying inward on trajectories astronomers can calculate but not stop. Jupiter isn't a passive planet holding onto its family. It is an active predator, one that has already eaten before and is now, patiently, over millions of years, doing it again. In a slow-motion sequence too gradual for any human lifetime to witness happening, but too consistent to be coincidence. If Jupiter has been quietly consuming its smaller moons for hundreds of millions of years, that reframes every stable solar system diagram you've ever seen, the ones with tidy circles and fixed labels. Moons aren't fixed points. They're temporary. Some of what we call permanent is actually mid-collapse, just moving too slowly for us to notice within one human lifetime, or 10, or 1,000. It also means the 4 faint rings around Jupiter aren't decoration. They're a graveyard, still growing, one orbit at a time, and they answer a colder question about the rest of the solar system too. If a planet this well-studied has been hiding a destroyed moon in plain sight, what else has been reduced to dust that we've simply mistaken for something that was always there? If Metis is doomed, and Adrastea is doomed, what does that say about every other moon quietly sliding closer to something we haven't calculated the timeline for yet? Nobody at NASA or Caltech will put a date on when Metis finally breaks apart. The models can't narrow it down. Somewhere between 10 million and 100 million years, they say, which really means they don't know. So the question isn't whether Jupiter is still eating its moons. It already is. The question is which one goes next and whether we'll even recognize it happening when it does. What do you think Jupiter's rings are hiding? Tell me in the comments.